Hello students, I am Raja Mohamed. Today I am going to talk about the basic structure of Turing machine. As we had discussed few things in the classroom regarding Turing machine, once again I would like to stress few points about Turing machine, that there will be an input tape and also an output tape. The assumption is made as if the tape is infinite in length. So, where the input tape will be having elements stored in successive order locations, which can be read, or even if we wish we can write something into it. And the tape will be having a read-write head which will be moving in either way, as you could see clearly here. The first element, second element, that means starting from A1, A2, A3, and it goes on. And this is the control, that is a read-write control, which is going to move in either way. Now say starting from the exclamation mark, that means first starting point until it reaches the last end. Okay, fine. So the tape goes up to certain limit, up to which input elements can be stored, right? Fine. Then what for the Turing machine is used? Turing machine is a computational device, right? So which is used as an abstraction for computing to be performed in modern day computing devices such as laptop or desktop, or even in smart mobile phones, etc. So assume we have data stored in a disk, that means that could be hard disk or USB or anything. When I say, if it is a case of a hard disk will have a read-write head and will also have array of disks. Now you want to read a file, the file may be stored inside the hard disk. That is what we know. But how exactly it identifies the file's location and how it reads data from that specific location. So these things are controlled internally by operating system. Operating system internal methods happening according to the model described in a Turing machine. Say the operating system instructs the read-write head to point to a particular location and start reading the content. And when you see the hard disk moving, disks rotating at higher speed, the read-write header must locate the exact position, right? So here you assume you have input alphabet to be read. Say for example here you have A, B to be assumed as input alphabet, and beta, the tape symbol, is used as blank. Capital B represents blank here. Assume in the hard disk you have data stored, say for example AA, BA, and the read-write header starts from the exclamation mark, that initial starting position. The output will be like when A is read, will be replaced with beta. Similarly for the next symbol also it will be replaced. Once it encounters a blank symbol, encounters the first blank symbol on the right hand side, it comes back to the exclamation mark and halts. So this will be done repeatedly for reading an element and erasing and replacing it with beta. That means when an input alphabet such as A or B read or written by a read-write header, it will be replaced by beta, so that next time we won't be reading the same thing again. Then here the same operation is stored in displayed in the form of an finite state diagram. It starts, checks for the exclamation mark, and if A or B is there, replaced with beta, and it reads to the right side by erasing them. And when it reads the first blank symbol, it goes back to the back side. That means towards the left hand side. And if it encounters any beta, it goes back. When it encounters the last exclamation mark, it says that it is almost done and it goes into halt state. So this is how erasing, read-write operation as well as erasing is done in a finite state Turing machine. So a Turing machine has to perform right side movement as well as left side movement. Right shifting a non-empty binary string is shown here. Say for example, input string is 1011. There is no starting exclamation mark and there is no end. So we need to put an exclamation mark so that it can be added to the left extreme end of the input. So it reads in a similar way what we discussed a few minutes back. It starts with 1 and replaces with x and 0 with y. So this can be configured in a configured for any Turing machine. Here you see to read each and every symbol we have states like x and y. So x says what the tape content to the left of the read write head. That means when you're reading the content from a tape from the left side, and y similarly denotes the remaining non-blank part of the tape. Non-blank in the sense you have data to be read, but it will be done in a step-by-step manner. And you could see here it starts with 1 and then goes to the right hand side with exclamation mark now replaced with exclamation mark. Now 0 is there, 0, 1, 1 is there. That means exclamation mark dot 0, 1, 1. That is state M1. That means it moves to the right side. And then when it reads 0, reading 0 and M1, it goes to M0. Likewise, the input will be read and replaced. When it reaches the blank symbol, it stops there. So it's switching between M1 to M0. That means mode 1 to mode 0 and mode 0 to mode 1. And when it reaches the last blank symbol, it starts reading the other way. That means earlier it was left to right, now it will become right to left, and then halts. So here the corresponding state diagram for the right shifting of Turing machine is shown here. And here this is a sequence of a Turing machine to copy a content from one specific track to another track. Here you could see here first it is reading symbols to be read and copies them into some other location, and then again marks all of them with the states and then looks for the last symbol. If so, it starts reading in the reverse order and copying all the elements again back to the new location. And the corresponding state diagram for copying contents from one location to another location. So this is not just only for moving one single element, rather this can be implemented for copying multiple number of cells or even multiple number of tracks and so on. So even to find the leftmost occurrence of a matching string, that means small x in a master string y, here this is a problem where we are matching one string and replacing with the other string. So this here you can see the input is as a match string, that is x, and a master string y. That means say for example master string y means he is a good guy, where I need to look for good as a string and it has to be replaced with very good. So you have a string which is you have a string in which a word is found out and it is replaced by another word given by user. Similarly, we can implement for implement the same thing when we have a complete string which is partially matching, which we will discuss in the next class. Thank you.